All right, we're going to talk about 6-7, graphing other trig functions. So far we've talked about how to graph sine and cosine. In this video, we're going to talk about all the others, what their graphs look like, etc. So my first one is tangent. Okay. If you look at a list of tangents, you could also look at what the tangents are on page 395 using the unit circle, or if you have your unit circle and you've done your tangents on there. You'll notice on that table on page 395 that every unit of pi we have undefined for our graph. So some interesting things about our graph here. This is going to go by pi over 2s, like our other graph. Okay, because that's how our unit circle looks. But if you'll notice there, all these places, they say undefined. So those locations are actually going to look a little bit differently. And actually, I was mistaken. The table here goes by pi over 4s. So I'm actually going to do that so you can see this graph a little bit bigger. Pi over 2, 3 pi over 4, and pi. Yes. You could do this one as by pi over 2s as well. It would just look a little bit more squished together. So you'll notice that all of the units of over 2, those ones are going to have undefined. So what we're going to do with an undefined is we are going to give it a dotted line. Okay. Thinking about those spaces, that dotted line, it tells us that it cannot cross that section there. That value does not exist there. So this is 3 pi over 4, 4 pi over 4, 5 pi over 4, and then 6 pi over 4, which is 3 pi over 2. So I'm going to put one right there so I can give myself another dotted line here. All right, so that means that we're going to break our tangent into functions, and our functions aren't going to exist at the pi over 2. If you look at this, at units of pi, we have a 0. It crosses through our 0, so that goes there. This one goes here, and then if I were to go over pi over 2, that one would technically be over here. Okay, and then in our next points here, it says that negative 3 pi over 4, well, I don't have that here, so negative pi over 4, I'm at negative 1, and at pi over 4, I'm at positive 1. So just looking at that table, these are going to be kind of periodic. So that one's going to look like this. And then our graph makes this S-curve. Okay, and this S-curve will be repeated every pi unit. So as pi again, that same S-curve is going to repeat, and that is our tangent. So let's talk about the things that matter here. Let's start with our domain. What is the domain of this? Well, our domain, what x's does it cover? It covers all of them except for units of pi over 2. All right. So that is, I was trying to see if there was a great way to write that. There we go. So our domain is all real numbers. So negative infinity to positive infinity. And that's supposed to be a parentheses, not bracket, except pi over 2n. So any value of pi over 2 does not fit in the domain. Okay, let's look at our range here. Technically, our range is going to hit every single y value. So our range is all real numbers. The max and the min, there isn't going to be a max and min specifically because it's going to go on forever. All right. Our y, let's see, our x-intercept hits right here at 0. But it also hits over here at pi. This right here is going to be negative pi. So we are at pi n for my x-intercept. My y-intercept only crosses right here at 0. We said we didn't have a max or a min. Let's talk about our period here. Okay. Our period goes for this amount right here, which happens to be a period of pi, which is a little bit different. And then the other thing that's interesting about our tangent graphs that are not in our other ones is we have an asymptote. And those asymptotes, they happen at every pi over n, pi over 2 in locations. Okay, so this means that they are undefined at those locations, which if you were to take a look at your unit circle, which I cannot find mine right now, at my unit circle, those locations would end up with like a 1 over 0, which is an undefined location. Okay. The other tangent we're going to take a look at is our cotangent, which is taking our tangents and flipping them. If you want to take a look at the table for our cotangent, that's going to be on page 396 in our book as well. Our cotangents are going to work the exact same way. For my cotangent here, I'm going to mark just the pi over 2 intervals here, but I'll skip one so that it's going to look exactly like my graph above. Okay, and you can see how they are just flips of each other. If you look on the page of 396, you'll notice that all of the locations where our tangent hits our 0, those are going to be all the locations that are undefined here. So that means at pi, I'm going to have an asymptote, 0, I'm going to have an asymptote, and negative pi, I'm going to have an asymptote. And those are all going to work that same way. So now we're going to take a look at these with our numbers here. And you're going to notice, like at pi over 4, our answer is 1, okay, which is what happened with our pi over 4 before. All those places where we had an asymptote before, those are all going to be zeros. All right, but over here, pi over 4, it said it was 1, which actually means that we are going in an opposite direction here. And that means that 3 pi over 4 is going to be a -1. And you'll notice that my curve curves in that opposite direction. Okay. Which makes sense because our cotangent is like the flip of our tangents. All right, so let's take a look at those important things that matter for my cotangent. The domain of my cotangent, that is going to be the same. We got all real numbers, except it's not going to happen at all of them. It looks like here we're at pi and the units of pi, those are not going to work. My range, same thing, that goes on to infinity. My x-intercepts, those are going to happen right here, now at pi over 2n. My y-intercepts, there's none. It does never cross the y-axis because that is an asymptote. My period, it still happens over the same period of time. So that is still my period. And my asymptote are going to happen at units of pi. Right. So now it says find each value using the graphs of these. So tangent of 9 pi over 2. So I'm gonna have to go up to my tangent graph. 9 pi over 2. So right here, I have 3 pi over 2. So I got to continue this out until I end up at 9 pi over 2. So I'm going to continue counting. It looks like there's 1, 2, 3 spaces between. So 1, 2, 3. Well, let's see. Actually, we'll count like this. 9 pi over 2, and then I'm going to skip. So sorry, that is 3 pi over 2. That's 4 pi over 2. 5, 6, 7, 8, 9. So this is 9 pi over 2. Okay, and then I gotta think there's 3 spaces. 1, 2, 3, asymptote. 1, 2, 3, asymptote. 1, 2, 3, asymptote. So let's see, our value of 9 pi over 2, it ended up on an asymptote, so that means we are at undefined. All right, so you've seen how we can use our graph to extend them. This one is taking a look at 7 pi over 2, so I got to do the exact same thing over here with 7 pi over 2. Because this is right here, you see how we have pi over 2s? This is going to be an odd integer. It's going to end up with a pi over 2. So I end up with 7 pi over 2. That's going to be on an x-intercept. An x-intercept means that we have a value of 0. So using the information that we know up here that pi over 2s are an asymptote, so that would also help us with a 9 pi over 2. Okay, so either extending your graph out or using the information we know. Okay, the next graph we need to take a look at is our cosecant graph. Remember, your cosecant is just going to be the flip of your sine graph. But I'm going to show you cosecant graph in a little bit different way. So I'm going to draw, first of all, I'm going to draw my sine in here because they are directly related. Okay, and then my units here, I'm going to go by pi over 2s. Pi, 3 pi over 2. Hopefully you can kind of see that. Negative pi over 2, negative pi. Okay, so that is my graph there. And now I'm going to draw inside of that graph my sine function, which is going to start at the middle, and it's going to go up and back down and around. I'm going to draw it a couple more times in both directions because I want to make sure you see how my cosecant works. So I'm going to draw my sine. All right, so I got my sine curve there. You can see it on there. Awesome, you can see it on there. So when I flip my cosecant, we learned up above that all of these zeros are actually going to become asymptotes. So that same thing happens here for my cosecant. Everywhere that is a 0 now becomes an asymptote. So I'm going to draw asymptotes at all of those zeros there. Let's see here. Here I drew a lot of examples for you, okay? So that is my asymptotes. And then how our cosecant works is our cosecant equations, they actually are U-shapes that sit right on top of my sine function. So they share the min or the max value, but my cosecants, that's how they look. They look like these U's that are sitting above and below, and they continue to repeat themselves. So realistically, if we just drew the black part, the dark part of my graph, that would be the cosecant, but this is how my sine sits right inside of it, okay? All right, so let's take a look at the pieces. Whoop, I lost my marker. All right. So you're gonna have to bear with me because I'm gonna have to write in pencil. My Sharpie annihilated itself. Oh, let's see if I can grab one more. All right, so let's go through this and talk about how my domain and my range and all those pieces are gonna work for this. See if I can find a sharpener Sharpie. Not really. This will have to work. Okay, so I'm gonna have to write probably big. So my domain, I'm gonna start there. My X values. Well, it looks like it covers all of them, except for, looks like units of pi. Okay. My range, my Y values here, well, it looks like it goes everywhere from 1 and up and -1 and up. So I'm going to say negative infinity to -1 and 1 to infinity. So this says we go from negative infinity to -1, including 1 to infinity because of where that sits. Okay. My x-intercept, does it ever cross the x-axis? Okay. Nope, that's none. Y-intercepts for this one, also none. Okay. Max and mins, it doesn't have a max or a min. It technically has a localized one, but not a actual max or min. And then our period. Okay, it looks like our period of this happens over 2 pi because we go up, down before we go up, down again. So that happens in a period of 2 pi. And then there are some asymptotes, and those happen at every pi in units. Okay, so that's our cosecant. Our secant graph acts exactly the same, but based off of our cosine. So let's take a look at what that secant graph is going to look like. So let's start with drawing our regular pi over 2, pi, 3 pi over 2, 2 pi. Okay. All right. Oh, this paper works better. I can get a better color for you. All right, so this graph's gonna look a little bit different here. We're gonna use our cosine now. So remember that this is kind of like using a cosine, and we're gonna draw our cosine in there. So I'm gonna make my heights not as tall. This one will look a little different than the secant. My cosine starts up here and works down and back around, okay, and down and back around. So here is what my cosine is going to look like. Okay. Everywhere that my cosine equals 0, that's where I'm going to still have an asymptote. So I'm going to draw my dotted lines here. Looks like it equals 0 here, here, okay, so I got all of those asymptotes for you. Inside those asymptotes, they're going to work the exact same as my other ones. So my dots are going to go like this and scoot around my asymptotes here and here and here. My cosine should be touching it, and here, and there's my secant. So the colorful part, that's my secant. The other one is going to be my cosine there. So let's talk about the important parts of my secant here. So we'll start with my domain, so my x values. Okay, if I'm going to talk about my domain, it's going to hit all of my x values except where my asymptotes are, and those happen at units of pi over 2n. My range, those are my y values, so this is going to be the exact same thing as our other one. We're going to go negative infinity to negative 1, and we're going to go positive 1 to positive infinity. Next, we're going to take a look at my x-intercept. Does this ever cross the x-axis? Looks like no. My y-intercept, does it cross the y-axis? Oh, it does cross the y-axis up here at 1. Okay. Same thing with those max and the mins. It doesn't really happen. They have localized ones. My period, it takes, to get back here in the middle, it's still that 2 pi. I'm thinking about because your cosine, your cosine is a 2 pi, and so is your secant. And then the last one is my asymptotes. And the asymptotes happen at every pi in unit. So that information can help you as you're solving. So I have 2 problems here. Now taking a look using my cosecant and my secant, it says find the values for pi for which the equation is true, so that my cosecant equals 1. So I'm going to pull up my cosecant graph here. And where does my cosecant equal 1? Well, it happens here, here, here. Let's see, that's 2 pi, 3, 4, so that would be 5 pi over 2. Okay, so it looks like it's odd units of pi over 2. Okay, and that's what our answer here is. So we're going to say pi over 2 plus 2 pi n, because that's going to get us around to another unit of pi over 2, which is where we end up with our odd units of pi. We need to know when our secant equals negative 1. Looks like that equals negative 1 at every odd unit of pi. So that's negative 1 pi, 1 pi, 3 pi. Okay, so we're going to need to think of how to write that, and it looks like we're going to write it as pi n, where n is odd. On the assignment, it's also going to have you do some graphing. You could use this information to graph our trig functions. All of the trig functions that are not my sines and cosines, you're welcome to kind of play around and try and graph them, but I'm happy if you want to use your calculator to graph those as well.